You may actually wonder what is really in this tutorial dataset. Now, here I will explain it with the original data that I used for the publication you find in the reference. Here you have again the RGB image, here the t-SNE scatter plot, and here a number of clusters that I selected. The first one here is dark red on AllPigment up here. Here this is not identical with the dark red color itself, which is in the outline of the figure. And why is this? If you look at the spectrum here, we have down here the XRF spectra, here we have the reflectance imaging spectrum, and here we have its first derivative. And what we see is that both spectra are rather similar in reflectance spectra, difference in average intensity, but okay. First derivative we have the same features, but that indeed we have in the red curve here a signal for arsenic. You see down here they are actually just the channel numbers and not the units. This is because the dataset was made with a much earlier version of the data handler P. If we now go further, we have here the skin color, which fills out the skin, and up here we have the AllPigment, which is here as a background for the hieroglyphs. The hieroglyphs are in ink which appear here. If we go now back to the spectra, we can indeed see that hieroglyphs and AllPigment are nearly identical in terms of XRF signal, but that the reflectance spectra differ drastically. Then there is below this something I called overpainted AllPigment, which has the same arsenic signal, but actually is more white in terms of reflectance spectrum. Then we're having there two kinds of repairs that are here around the collar and here up in the upper left corner. And they are rather similar, they just differ a bit by the signal, by these two signals. This is mostly chlorine, if I'm not mistaken here. Then we're having here this area to the right of the face, which we have to take in comparison with the background, which is here. And if we do this, we see that this area, this blue area, has actually a much higher iron signal, but it's not too different in terms of reflectance spectrum. And this is because the face was originally painted further, stretching out, and then after it was painted, limited again by the application of white paint. There's no reflectance from the red paint under the surface still detected, but the much more penetrative X-rays go down there. Then we have here in the color two different forms of Egyptian blue, which we see here with the characteristic spectra and the high copper signals. We have them in two different shades, darker and brighter. So we have also a clear difference in copper signal. The more copper, the more absorbing. Also, we have the Egyptian green, which also has a strong copper signal, but here we have a slightly different shade up here, which is not really characteristic for Egyptian green, but it lets us believe that it was there also from the context and other objects. We're having here also a little bit of the Egyptian blue shape in it, because it's round and partly shared between pixels, as the resolution is not perfect in this data. And that's what you can find back in this dataset, and I wish you good luck with it, and have fun.